everybody, this is Notes 52, and we're using Trig to find angles today. So yesterday we were finding sides, today it's angles. Before we do that, we do have to learn something new about solving equations. So we know that if we were going to solve for x, right, in many equations, we do the opposite of something. So if I have addition, I subtract 2 on both sides, I get x equals 7. And then let's say I have the square root, I do the opposite of square rooting, which is squaring, and I do it to both sides, and the square roots cancel, I get x equals 81. So those are pretty simple, but when we look at this one, we don't really know what's happening here. So we're taking the sine of this angle, and it's giving us 14 over 15. But in order to get that x out, it's sort of like stuck in these parentheses like we're used to. The opposite of taking the sine is taking the inverse sine. So you might see this on your calculator. It's under, if you press second and then the sine button, you'll be able to find this. And what happens when we do that is that this and this cancels, and just x is what is left over. But we can't forget that what we do to one side, we have to do to the other. So I'm going to actually take the sine inverse of 14 over 15. Sine inverse 14 over 15, and I get 68.96. And then that's going to be degrees because I know that it was a sine. If I go ahead and take the sine of 68.96, I should get something very close to 14 over 15. Should be almost exactly the same thing. So if I want to do the inverse of this here, I do sine to the power of negative 1. It's called the inverse sine. Take the inverse sine. That cancels these. Leaves me with 75.93 degrees. The same is true for cosine and tangent. So the opposite, or the inverse of cosine is inverse cosine. Just like this. Cosine to the power of negative 1. Cancels here. Gives me x equals, and I do in my calculator, cosine to the power of negative 1. Negative 2 divided by 10 is 101.54 degrees. And then same exact thing for tangent. So this is a little overkill, but if we have tangent to the power of negative 1, we also do the inverse tangent over here. That gives me x equals inverse tan of 3 over 5, which is 30.96 degrees. So the cardinal rule of equation solving is what you do to one side, you must do to the other. And that keeps your equation balanced. Do to the other. Right, so as long as you do this, you can do whatever you want to the equation, so long as you keep that in check. So we're going to use that today. Other than that, it's going to be exactly the same. So remember this from before. Identify the unknowns, or the unknown and the given. You're going to decide which trig function to use. Remember, we're thinking about SOHCAHTOA still. We're going to write an equation, and then we're going to solve it. So we'll do one example here. The unknown is this angle here. So we'll put a question mark there, and we'll just say that is an angle. We can call it theta if we want to. And then givens are the number 11 and the number 27. I'm going to go ahead and decide what they are. So that would be 11 would be the opposite. And then the 27 is the hypotenuse. So I see that I have opposite and hypotenuse. So it looks like sine is going to be the right way to go because I don't have adjacent for either of those. So I have sine here. I don't know what that is. It's a question mark. Instead of using a question mark, we would normally use the theta. And so it's just a circle with a line through it. And then sine we know is opposite over hypotenuse. So I have my opposite, which is 11, over my hypotenuse, 27. So I'm going to go ahead and write my equation in box 4. Sine theta equals 11 over 27. I need to get my sine by itself. My angle by itself. So I'm going to use inverse sine. Take the inverse sine here. What I do to one side, I have to do to the other. That cancels my sine, and I'm left with theta equals I'm doing my calculator, sine inverse of 11 over 27, and I get 24.04 degrees. And if I look at my angle here, that looks like it could be about 24. It looks a little smaller than the normal 30, and so we know that this is a valuable answer. Very simple. The exact same 4 steps. We're just doing something a little bit different here that we learned at the top of the video. Step 2 here, example 2 here, same exact thing. My unknown is theta. My givens are 7.7 and 14. I'm going to identify from theta. I'm going to go opposite over here. 7.7 is my opposite. I know that the long side or across from the 90 degrees is my hypotenuse, and the leftover is adjacent, so I know this must be my adjacent. I need the one that uses opposite and adjacent, which is this one here, tangent. So I have the tangent. I need to know theta, right? And it's opposite over adjacent. So my opposite was 7.7, my adjacent was 14. In order to solve this equation, I need to take the inverse of tangent, which is the tan inverse. Use that button on my calculator. I'm going to cancel here. Theta is equal to inverse tangent of 7.7 divided by 14 is 28.81 degrees. I can check it out and see, does that make sense? Yeah, that looks right about true. And so I can do that. Go ahead and do example 3 here on your own and get it checked off by me. Thanks, guys.